Now, when you did the section on formulas, they weren't actually trying to get you to use the formula, they just wanted you to manipulate the formula. So this one wants you to get the b by itself. So the first thing we're going to do is we're going to get rid of that 3, because that 3 is getting in the way. So on this side, we have 3a, and on this side, 3 divided by 3 is 1, so I'm left with a plus b plus c. Makes it, again, really easy, just like we just did with clearing the fraction. Same technique. The common denominator, well, there was only 1, and it was 3, so we multiplied everything by that. And this portion right here is on the top of a fraction, so I think that the numerator is all one piece. So now, getting the b by itself, I'm going to subtract that a from both sides. Notice they're two different a's, so I can't subtract them even though they're both a's. That's 0. And I'm left with b plus c. Now I want to get that c away from both sides. On this side, I have candy corn and Smarties, so 3a minus c. And on this side, that makes a 0. I'm left with b. And that's what I was looking for. The next section was on absolute value and using absolute value, not just on absolute values. So when we first look at the first problem, we're asking ourselves, what can we put in here that's going to give us a 17 as an answer? So if I put 17 in there, 17 gives me 17. If I put negative 17 in here, I should get negative 17 over here. Let's check it really quick. If I put negative 17 in here, I definitely get 17. And if I put 17 in there, I get 17. So I'm good there. Now that we went in a little bit more difficult problem, this one has a lot more things to look at before we get to that point. We want to treat it just like an x and solve for x. Don't worry about the absolute values, just think of that x as x. So we want to get rid of this 1. It's adding 1, so we subtract 1. 1 minus 1 gives me 0, and I'm left with 2 times the absolute value of x. 15 minus 1 is 14. Now I want to get that x alone, so I'm going to divide both sides by that 2, opposite operations. Absolute value of x equals 7. So now again, knowing that my absolute value equals 7, then I know that positive 7 and negative 7 should work. So let's go back and do a little check. 2 times the absolute value of x plus 1 equals 15. And let's start with the positive 7. The absolute value of 7, think of it like parentheses. I got to get rid of the absolute value first. So the absolute value of 7 is 7. 7 times 2 is 14. And 14 plus 1 does equal 15. So let's try it with the absolute value of negative 7. So the absolute value of negative 7 would be 7 times 2 is 14 plus 1, and it works as well. So you reviewed proportions, and proportions you've been doing for several years, so it's just a quick review. In the case of using it in algebras, we know that this fraction equals this fraction, so that helps us be able to solve for y. And what we've used for so many years is cross multiplying. So 3 times y is 3 times y, and 5 times 12 is 5 times 12. Clean up that. 5 times 12 is 60. Simplify by dividing both sides by 3. Y equals 20. Okay. Then you went into percents, and we're looking here. Write this as a decimal. So remember that when you don't see a decimal, the decimal's right here. So in the case of these two, there's the decimal. This one already has it. When you're changing from a percent to a decimal, you move your decimal 2 places to the left. So instead of 48%, we get 0.48. Instead of 145, the point was right there, we get 1.45. Instead of 0.5%, we get 0.005. So remember, when you're writing a decimal from a percent, you're going to move 2 spaces to the left. Now we're going to take a a number and write it as a percent. So we're going to go backwards. A couple of things you can do here. You'll notice everyone's a fraction. Percent means per 100. So I know that I can get from 4 to 100. I can set it up as a proportion. What percent, what per 100, what I have. Now I can just simplify it and use percentages. So I know 4 times 25 equals 100. So 3 times 25 would be 75. That's one way you can do it. Down here, if you do the same thing again, you can do your cross multiplying, and you get 12.4 times 100 and 25 times x. Multiplying here would be cleaning that up. And now we divide by 25. Let's see. If I take 2450, I can't divide by 25, but I can divide by 5. So if I divide by 5, I get 248 on the top and 5 on the bottom. Oh, you know what, I'm just going to stop there. I'm going to go back. How far back am I going to do? Want to just give me, come on. Okay. Okay, back in 3, 2, 1. So the other way we can do this is we can say, okay, 8 goes into 3 how many times? So 3 and 8. 8 can't go into 3, but it can go into 0.3. How many times can 8 go into 3? 3 times, giving me 24. Okay, so now we subtract. We get 6, bring down that 0. 8 can go into 60 how many times? 7, and we get 56. And now 8 goes into 40 5 times. So we have a decimal. Now we go back to that last section we were doing where we went from percent to decimal. Now we're going to go from decimal to percent. So we moved it 2 to the left before. Now we're going to move it 2 to the right. 1, 2, and now it's here, so this equals 37.5%. So you can either divide the top by the bottom, or if you have a problem that works out very nice with 100, you can do that as well. You can also use proportions to help you in that section. Okay, so now we're looking at percentage again, and this is what percent of 40 is 15. You'll probably remember that part over whole equals percent over 100. And remember, you just have to make sure you're breaking it down the right way. We want to know what the percent is. So we don't know the percent. We know it's over 100 because that's exactly what percent means, per 100. So now you have to figure out what's the part in the whole. What percent of 40? Now you're taking something of 40. So that's my whole, and my part is 15. So now we cross multiply. 15 times 100 equals 40 times x. I get 1500 equals 40x. Now we divide by 40. So one thing I did before I did the problem is I said I can see that I can take a 0 from both. Actually, that would be dividing by 10. I could divide the top by 10 and the bottom by 10. Kind of makes my problem go a little bit easier. 4 goes into 15 3 times. There's your 12. 4 goes into 37 times, 28, 2 left over. I need to add that decimal and a 0. 4 goes into 25 whole times. So now I know I've got a decimal 37.5. Well, it is, in this case, it is the percent because the x is per 100. So that is my percent. And the last problem here, we're looking at part over whole equals something, or percent, pardon me, percent over 100. So we look here, we already have our percent. Our percent is 16 over 100. Now, 3 is 16% of what number? When you're taking a percent of a number, you're taking a piece of the number. So if I'm taking a percent of this number, this is my whole, this is my part. So my part is 3, and I don't know my whole. Here we go. So we get 3 times 100 and 16x. I get 300 on this side and 16x on this side. Divide by 16, and x is, so again, let's put the 16 into 300. I have a feeling we'll need that decimal. Can only go in one time. Bring down the 0. So 16 goes into 40, a little more difficult, but it's going to be 8 times, and you get 128. Here, you borrow from the 4, making it 3, 2, 1. Bring down that 0. 16 goes into 12, or 127 times. 11, and we're going to have 8 left over. And 16 goes into 85 times. So we're looking at the answer being 18.75. That's how many you started with.